Hi there, and thank you for clicking on this video. In this video, I wanted to do kind of a side lesson, something really quick on how to convert units without cluttering your brain. And in my experience as an educator, unit conversions are often overcomplicated. They involve I don't want to make it sound like I'm against thinking because I am 100% in favor of thinking, but they're presented in a way that involves more thinking than it should involve, and we don't need to do that. We've got enough things that we need to process in our brains and enough things that are really challenging without making something more complicated than it needs to be. So a great way to do unit conversions is using proportions. And what I love about this is it works in almost every situation. And I did have to put in the almost in there because the way to do this with Fahrenheit and Celsius conversions is a little bit different. So we're not going to talk about that in this video. And there might be some other things that fall under the same umbrella as Fahrenheit and Celsius conversions that would be similar. Comment below if you'd like to see that in a separate video, because that one is a little bit different. I think because we're like looking on a scale where we're moving like up and down, like warmer and colder. Now, the first thing I want to do is review how proportions work. Okay, so we're going to look at how proportions work. So first off, what is a proportion? A proportion is a comparison of ratios in which cross products are equal. Now, that might not have worked for you. I know I just went a little bit mathy there with how I said that. A comparison of ratios, there's a lot of vocab in there. But let's take a look at a couple of examples. Okay, so 1/2 is a ratio. It's 1 out of 2. So if you have a whole divided into 2 parts and you're taking one of them. So for instance, here's my whole. It is divided into 2 parts and I have 1. And let's go with the good old pizza. A pizza is usually divided into 8 slices. And if you take 4 of those 8 slices, you have the equivalent of half a pizza. So looking at this, it would look something like that. Like there's my whole, and this time we are taking 4 out of the 8. And if you look at the shaded sections there, that is the same amount. So 1/2 is equal to 4/8, or 1 out of 2 is the same thing. There's our equal sign as 4 out of 8. Now, what we mean by cross products is this. Okay, and there's some vocab here too, like the means and the extremes, but this is what we mean by cross products. It's where we multiply on the diagonal, and in a proportion, if the ratios are equivalent, then the cross products will be equal. So 1 times 8 is the same as 2 times 4. So 8 is equal to 8. And we can look at this with some others. So let's look at, say, 2/3, and that is the same as 6/9. Okay, so 2/3 is the same. And I could do the same thing where I drew out a picture and said, okay, here are 3 parts. We're going to shade in 2, and here's the same whole. We'll divide it into 9 parts. We'll shade in 6. And here's what we mean by the cross products. So 2 times 9 should be the same value as 3 times 6, and they are. And so I know that those 2 ratios are equal. Okay, and that's what we mean when we say a proportion, that we have 2 equal ratios and they have this attribute that the cross products are going to be equal. Now, that really is a review highlight from something that would come out of a lesson on proportions, which this is not. Okay, but that gives you an idea. Now, when we are doing unit conversions, we are looking for equivalent ratios, so proportions are a great way to get what we need. We are looking for, say, let's look at some examples. Okay, now here's how it works. This is kind of an overview. If this is a little bit confusing, just hang with me. We're going to go into some examples that I think will clear it up. But we're trying to convert between two units, say length, time, so forth. Okay, so you've got something measured in hours, but you need it in minutes or seconds. You've got something in centimeters and you need it in inches. Okay, so I mean, it could be many, many different kinds of things. We either know or can look up the conversion factor. So you might know a conversion factor off the top of your head. So most of us would know that there is that 1 minute is 60 seconds. That for most of us is not something we're going to need to look up. But we might need to look up something, say miles to kilometers. Okay, although I'm going to show you a way that I get around that. But you might have to look that one up. Like that's not one that you know. Now this conversion factor becomes one ratio in our proportion. So if I've got my two equal ratios, one of those ratios is the conversion factor. Okay, now the other ratio will consist of the known value and the value we're looking for. So in the other ratio, you might have an X on the top and then a known number on the bottom, or it could be the other way, depending on how you set it up. So your unknown, the thing you're looking for, might be on the bottom and your known numbers on the top. So it could go either way. So you're going to have one ratio that is your conversion factor, and then the other ratio is going to have the thing that you're trying to convert, say 3 minutes, and you want to convert 3 minutes into hours, and then so the hours would be your unknown. Okay, so we're going to work through an example or two. I recently returned from a trip to Europe, literally within the last week. Now, I traveled with US dollars because that's the money that I have, but the euro is the currency used in Greece and Italy, which is where I was traveling. Now, at one point during this trip, we kind of voted as a group to do this side trip to an Italian village, to a Greek village and an Italian village. And to do that, it was going to cost us 15 euro. And the tour group leader does not want to be paid in dollars, needs the money in euros. So it was 15 euros for the side trip. And I only had US dollars on me. So I needed to find a way to convert my US dollars into euros, but I don't want to convert all of my money into euros. Like then, what am I going to do with all those euros? But I also didn't want to come up short. So the question that I had was, how many US dollars did I need to convert in order to make sure I had at least 15 euros? And I really want to draw your attention there because the at least is actually an inequality more than an equation, but we can get there from here. All right, so that's the problem, and that is an actual real life problem. Like a week ago, this was what I was dealing with. Like, how am I going to get 15 pounds or 15 pounds? I keep wanting to say pounds. They're euros. 15 euros to the tour group leader when I only have dollars. Okay, so we're going to date this video. Okay, so here's the current conversion rate between dollars and euros. I went online. 1 US dollar is equal to 0.88 euros. And that was updated this like at 4:17 p.m. UTC, whichever time that is. Anyway, so that's what it is today. Now let's work the conversion with a proportion. Now, what we need to do is we need to decide like the two things we're converting between are dollars and euros. Now, I can set this proportion up one of two ways. It does not matter which way I set it up as long as I don't change my mind halfway through the problem. So once you decide which way you want to do it, like, got to keep going. And here's what I mean by that. I'm going to set up my proportion like so. And I can put either the euros on the top and the dollars on the bottom, or I can put dollars on the top and euros on the bottom. It does not matter. Okay. What matters is that once I decide which values go where, I have to like commit to that. Okay. And so I'll kind of work this out both ways just so you can see how that works. So one of my ratios is going to be my conversion factor. So if I do it this way, where I have euros on the top and dollars on the bottom, then I know that 0.88 euros is equal to $1 US. On this one, it would be $1 US and 0.88. So you just like line that up. Again, doesn't matter which way you do it, as long as once you commit to it, like you stay with it. Now, I needed 15 euros. So that 15 needs to go into the other ratio, and it was 15 euros. And so because it is euros, it needs to line up with whichever line I said euros was going to be on. So if I put euros on the top, then the 15 goes on the top. If I put euros on the bottom, then 15 goes on the bottom. And then my unknown is the dollar amount, because that was the problem. Like, how many dollars did I need to go and exchange to make sure I would have 15 euros? So that's how that works. Now we're going to use this cross products are equal in order to figure out the unknown value. And you'll see here that it's going to work out the same way both ways. So I have 0.88 times x is equal to 15 times 1, which is 15. If I come over here, I've got 1 times 15 is 15. And 0.88x. So you can see that we land in the same spot. Okay, that is the same equation both ways, which is why it doesn't matter which way you set it up. What's going to throw you off is if you say, I want euros on the top and dollars on the bottom, and you do one of your ratios that way, and then you flip the other ratio upside down, because now you won't have the same situation with the cross products. And then we will divide both sides by 0.88. And this ends up being, it's like 17.045. It keeps like repeating, but we'll say something like that. So about $17. So when I go with my US dollars to like a place to convert my money over, like an exchange place, like I know I am going to need to convert like about $17. Now, just for those of you that haven't traveled, there's like an exchange rate, and then different businesses, because they are a business of exchanging money, might not give you that exact rate. And so you still want to go and make sure that you look at like wherever you're going to be converting your money, to make like to see what conversion rate they're giving you. Okay. So just like heads up. So about $17. Now, a lot of conversion places won't accept $17. So probably what I'm going to do is I am going to, for practical purposes, convert 20, because remember, this was an inequality. It was at least 15 euro. Like I can't come up short on the 15 euro. So at least 15. So if I go and I convert 20, then I know I'll have the 15 euro, and I'll have a little bit extra to spend. Maybe I can buy myself a soda or candy bar or something like that, something from a street shop that doesn't necessarily take, my credit card. So there you go. And of course, setting it up the other way will work as well. Now, what I really love about this, and I'll mention this at the end of the video, is this method works regardless of the direction that you want to convert. So you don't have to get separate conversion formulas in order to work the problem different ways. And that can be a huge time saver. So like if I've got a conversion that says $1 US is 0.88 euro, if I wanted to go the other direction, and I have a certain number of euros and I want to see what they are in dollars, I don't have to look up another conversion factor. It would simply look something like this, where I would have my euros and my dollars and 0.881. And let's say like now I say I've got my $20 and I want to know how many euros that is. Okay. And so you just make sure that you put your known in the right spot. You have your unknown in the right spot. And so it would work the same way. So 1 times x is just x, and then multiplying this way 0.88 times 20, and I kind of did this on the spur of the moment, so I don't know exactly what that is, but we can find out. 17.6. And that would be euros. And so that's what my $20 would give me on that. So a big advantage to that is you do the one conversion works both directions, and that can help avoid what I mentioned at the beginning, that brain clutter of just like kind of too much stuff going on. Okay, a second example. All right, so I am an avid runner, and while I don't know the exact conversion between miles and kilometers off the top of my head, I do know that a 5K running event is 3.1 miles. Like, that is a number that I have like right in my head. 5K, 3.1 miles. I also know that a 10K is 6.2 miles because this is something that I do all the time. So that I just know. Could I look up the actual conversion? Yeah, sure. Now, let's say I am on my trip and I ask for directions to Trevi Fountain from just, let's say, the waitress at the restaurant where I'm having lunch. Like, I want to go to Trevi Fountain, how far away it is. Well, if I am in a foreign country, they are probably not going to give me that distance in miles, which is something that I have a sense of how far it is. They're going to give it to me in kilometers. So I am told that it is 0.5 kilometers away. So maybe the waitress says half a kilometer away. How far away is that in miles? Okay, I need to put that into some kind of number that I am comfortable with. So here's how it would work if you don't have like an exact conversion formula. So the two things I'm converting are kilometers and miles. And again, it doesn't matter whether I decide to do miles on top or kilometers on top. Like, that does not matter as long as once I pick where I want them to go, they stay put. So I know that a 5-kilometer race is 3.1 miles. That's the ratio that I know. Okay, or 3.1 miles, 5-kilometer race. And what the waitress told me was that Trevi Fountain was half a kilometer away. So when I go to put that half in, I just need to make sure that I put the half in the kilometers line, okay, where I have decided to put kilometers. So in this case, it's 0.5. And then what I want to know is, what is that in miles? And so over here, we'd have the okay, and there's my unknown. So I go and do my cross multiplication because that's how proportions are. So 5x is equal to 3.1 times 0.5. 5x is equal to 1.55, and then we divide by 5 and we get 0.31 miles. So about a third of a mile, or if you're like familiar with a track is a quarter mile. So this would be like 0.25 plus some. Okay, so not quite 2 laps around a track. So about, a third of a mile, 3/10 of a mile. And that just gets it into a unit that means a little bit more to me. Now, this you could actually do a quicker way. And this is another great way about doing the proportions out is most of us, like in our heads, we don't do 1.55 divided by 5. Maybe you can. But what I can notice once I set the proportion up is that is dividing by 10. So 5 to 1/2. So basically you moved the decimal point left 1. And then you would do the same thing right here. So you would take the 3.1 and move the decimal point left 1 and get it that way. And so that is probably a much more efficient way to do it. So once you set the proportion up, you might notice something like that, like, oh, look at that. I could just like divide by 10, which would also be a perfectly valid way to do this. So why is this a great way? First of all, like I mentioned this earlier, it always works, and it works in both directions. There's no need to try to remember if you're supposed to multiply or divide by the conversion factor, which a lot of my students would do. They're like, wait a minute, the conversion factor is like, you got that 0.88. Oh no, should I multiply by 0.88? Should I divide by 0.88? Now, you should be able to get a sense of that based on like which unit is bigger. But a lot of students do struggle with that. And so like setting up the proportion is going to take care of that. It works for any known conversion, not just conversion factors given on a reference sheet, which I tried to demonstrate. So if you don't know like 1 mile is this many kilometers, but you do know that like 5K is 3.1 miles, any known conversion will work. And it helps build towards pattern recognition and estimation, which is more practical because at the end of the day, I don't need to know exactly the dollar amount. I need to know like about the dollar amount. So, $20 is close enough. And so by doing it this way, rather than just like throwing it into a formula or just like pulling it up on your phone and making your phone do it, you're developing some of the reasoning that's going to serve you well later on and actually be more practical. So I hope this like short 20-minute, like, hey, great way to do conversions is useful to you. Let me know in the comments. I hope to see you in a future video.